Yeah. Can we do the admin every time?
Recording in progress.
Perfect. Let's start. So formal good morning to all the people online and all the people in person. So this workshop is going to be about natural language processing. The way we are going to move forward now is that for up till now we had the common workshop, right? So we had something on Python, we had something on basic machine learning. Now we'll be moving towards the tracks. So now we have total 3 tracks. We have the core machine learning, we have computer vision, and we have natural language processing. So for natural language processing, for now we have designed mainly 2 workshops, out of which this is the first one. The pattern for the workshop is that we'll be telling you a lot of material, and I completely agree that in 2 hours going through all of this material is very difficult. So I would really urge you to see the video again, and there will be a lot of links. There are going to be many Google notebooks for you, so you can and they'll be completely runnable in the sense you can click on the Google notebook and try and fiddle with it. So you can try and change the different parameters that are present in the notebook and try to get better with your understanding. Okay. And
one input would be like, if you feel like you're stuck at any point, like just feel free to ping any of us, because I think like all of us have took help from our mentors, and
Definitely.
I think this is not some area wherein like you just get better overnight. So I think at any point of time, if you feel stuck anywhere or if you're not understanding something, even during the workshop, you can just like interrupt us and ask questions.
Also, I might have to leave like a little early, like before 12:30 because I have a class, but I'm definitely gonna like watch the recording.
Sure. Works. Okay. So let's dive into it. So these are basically different exams. Can you find something that is common in them? So we have the Wharton MBA exam, the US medical licensing, law school exams, and the Stanford medical. Have you seen the news recently, or do you think that there is something common? Yeah, actually,
no, the hint is it is something related to NLP. Like this has nothing to do with the exam.
yeah.
Oh, okay. Wait, what was the hit?
This has something to do with
What we're going to learn today.
Yeah, what we're going
Yeah.
to learn.
Oh, okay. Like it's graded based on like.
Yeah. So first of all, one thing which I can see right now that there is nothing common in them. In the sense they are so diverse. Yeah. There is an MBA exam, there is a medical exam, you have law and whatnot. But this is the thing which is common. ChatGPT.
Passed all the exams.
Even they being so diverse, having nothing in common to say so, but ChatGPT happens to excel in all of them. And ChatGPT is basically what? It's natural language processing. What we're going to learn. Moving forward, what is NLP for you? So since you've joined this particular stream, I'd like to know like what are your expectations? What do you think about natural language processing? Thanks for sharing that.
Yeah. So in this, basically looking at what do you want to have as your potential outcome. You have natural language processing divided into like a natural language understanding, in which basically you're trying to find out what the text is about, trying to get more information out of it. And the second part is natural language generation, which is basically, okay, now you have an input, you're trying to get more out of it. Like with the ChatGPT, you're getting a response. You're just typing in a few lines of like a question, and you're getting a big response. So that's like natural language generation to create the text basically from the original data. Same with video summarization or story writing. You just give him a input, and then he'll start to create its own data from there. So, and then he'll basically use that output as well with the story you have. It has to be aligned, right? So whatever output is using, he's making sure that the next output is based on the previous one. So it's basically like a cycle. So it's taking on from there. Yeah.
So now let's move towards some applications of NLP. So as Devendra rightly said, NLP stands for natural language processing. So whatever we humans talk in, so and another myth is that NLP is only restricted to English, and that's not so. So whatever language humans converse in, our goal happens to be two-way. First is the machine should understand what we say, and at the same time, machine should talk to us the way we talk to it. That is what natural language processing is all about. Now, there are some very famous tasks present in in natural language processing. So we'll just go over the current applications where NLP is being used. So first is sentiment analysis. In sentiment analysis, what we are trying to do is that given any text, we are trying to judge what is the sentiment of it. So is it positive, is it negative, or is it neutral? So when I say something like, I loved the food at XYZ restaurant and the pizza was really tasty, this indicates a positive sentiment. So for example, one of the example is social media monitoring. So there are examples of 2016 US elections, 2018 elections in France, if I'm not wrong, 2019 India elections that sentiment analysis was used. So for example, let's imagine that, there are two candidates and there are a lot of tweets or a lot of posts that are being made about them. So using that, you can try and guess that, for example, let's say Devendra here is standing in an election. So the number of posts for Devendra is 100, out of which 70 are very positive. So we can say that maybe Devendra is kind of in the lead. Then we have text classification. So text classification is a very big umbrella wherein you try to categorize the data that you have. So a very good example will be email spam filtering. So for example, if you use Gmail, some of the emails will be directly put in the spam folder, right? So this is basically natural language processing text classification at work. What we actually check in the text classification for spam filtering is that what's the grammar that is being used, what is the length of the text that is being sent in the spam email, so on and so forth. And if it matches a certain pattern and it looks like to be spam, it will just throw it to the spam folder. But now with ChatGPT, a lot of that is going to change. There was an assumption, rather a presumption, that spam emails will contain bad language, they will not be drafted well. But with ChatGPT, that's going to change. ChatGPT can give you very well drafted messages. So maybe that's something that is gonna change the spam filtering a bit. Yeah. Moving on, we have text summarization. So as Devendra said, we have mainly two parts here, NLU and NLG. So one of the applications is that you're bored with all this big slides. Yeah, you don't want to go through this. You have your lectures and there's a lot of material that your professor has given you and you want a short summary. So you can ask your computer to do that. Abstractive natural language generation, in the sense that you're given a paragraph and the machine will try to understand it and generate a summary out of it that need not necessarily be of the words that are present in the paragraph. So for example, Ram is playing and eating food and swimming. So an abstractive summary of this could be Ram is an active kid, something like that. Yeah, loosely, but this is what I'm trying to say, that that's abstractive summarization. Extractive is that whatever paragraph you're given, you just extract important points of it and present it. So extractive in the sense happens to be part of understanding. Then we have machine language translation, where you translate multiple languages. So for example, Google Translate is a great example of that. You happen to visit France because of your love for Paris, and you happen to know French. So what do? You can use Google Translate. What is at work? Natural language processing is at work. We have text analytics. So there are different e-merchandise websites, for example, Amazon, eBay, and all that stuff. So there are a lot of comments that are being posted on it. There are a lot of surveys that are being collected by these sites. And what we are trying to analyze here is that what are the main topics that people are talking about? So for example, if I have a product, I've manufactured a laptop and a lot of people are talking about the keypad not being good. So if a machine can analyze that and tell me that, the topic keyboard is appearing a lot of times, can you do something about it? So that helps me with my business, right? And of course, finally, chatbots and virtual assistants, that's something that I guess we all know of, we have already used of at least once. And ChatGPT happens to be the best chatbot that there is, and kind of a scary chatbot, if I may say so. And yeah, let's move on with this. So we have the natural language processing pipeline. Devendra would like to take this. Okay. So what happens in a natural language processing pipeline is that what we're going to see is how does the project start and how does it end. So can we try to rescale this or oh yeah, thank you. So any natural language processing or per se any machine learning project always starts with data collection. And we cannot emphasize enough how important this step is, because the data that you want to collect should be coming from reliable sources, should not be polluted in the sense there should not be a lot of dummy values in them if you're going for an actual project, of course. So the first most important part is data collection. Then we move towards text cleaning. In the coming slides, we're gonna actually try and understand what is text cleaning and why it is important. We have pre-processing of the data, feature engineering, wherein you try to extract important features from the data. For example, in the spam filtering example that we checked, yeah, one of the features that I can extract is the length of the text. So usually emails which are sent by valid users may have a bigger text than the spam mails. This assumption might be true or might be wrong, but what I'm coming to is that these are the certain features that you can extract. You can extract the sentiment core, which can be another feature. You can make the complete text as a feature. So we'll come to that later. Once that is done, then you model your data. So now modeling here is very generic, depends on your tasks. What do you want to do? You want to do sentiment analysis, you create a model for that. You want to do text summarization, you create a model for that. So this modeling block can encompass almost anything, and it's highly specific to you, the task that you want to do. Then you move towards evaluation of your model. And evaluation in the sense is the arrow kind of suggests it's a one-way process, but imagine that after evaluation, there is another loop back to modeling. So there a lot of back and forth is what you do. So evaluation, you find out your accuracy is not good. Then you fine tune your parameters and you go back to modeling. So this cycle will continue till then you're not happy with your model as suggested by your evaluation. Once you have that, then you move towards deployment. That is chatbots or things in action. For example, the Google email spam filtering is actually a deployed model. ChatGPT is a deployed model. Any virtual Google Translate happens to be a deployed model. And once you are done with your deployment, you continue to monitor and update your model. So for example, if you guys might be knowing that ChatGPT is indexed till 2021. It has limited knowledge of data after that. So in the next release, maybe when they come out with GPT-4 or maybe this just enhanced ChatGPT, they might update the model with data after 2021. So that is the updating procedure. Now, the first part of it, that is gathering data. So these are basically the top ways in which you can gather data for your projects or for your assignments. So there are a lot of online data sets available. We have links to many of, like, we can't give you an exhaustive list, of course, but these are maybe the most famous ones, if I may say so. So we have Kaggle, you might have heard of it. Kaggle hosts competitions. It also has a lot of free data sets. So what do I mean by a data set? So data set is basically any collection of things like reviews. It can be, if it depends on your task. So in core machine learning, if you want to do classification, so let's say I'm recording the housing prices in Los Angeles. So anything of this sort is data. Now on Kaggle, you'll find huge data sets. It's up to you what you want to use from that data set. For example, what we saw in feature engineering, right? All the features that are presented in the data set might not be useful to you. So you might want to extract particular features from it. So just be aware of this when using data sets from online platforms like this. Next is web scraping. So you have libraries like Beautiful Soup, Scrapy, and Selenium in Python, wherein you go and extract data for yourself. So for example, there are a lot of sites that show you stock prices. So you can use Selenium and record the stock price of a particular ticker So for example, I'm interested in the stock price of OpenAI. Well, I'm not sure if they're openly traded, but any bank, yeah, I want to go with I want to understand the stock price. So I'll keep a for loop or a while loop in my Python, wherein in every 5 seconds and in every 10 seconds, I go and record the stock price using Selenium. Next, we have REST API calls. So for example, if you don't want to use the GUI base of it, there are certain servers where you can send REST API requests and they'll just send the data back to you. So one of the examples is Words API. So Words API will, if you send it a request with, let's say, give me synonyms of the word lecture, and it will send you the synonyms. It can send you antonyms, so on and so forth. And the final one is crowdsourcing. And this is a very important one when you actually try, when you will be doing projects in real life. So for example, if you want to build a chatbot for USC, one of the ways you is that you send a survey to all the USC students asking them, what are the difficulties that you're facing? What are the questions that you want to be answered by the chatbot? So in this way, you're crowdsourcing to receive data. Pre-processing. So now this is a very, very important step in natural language processing, that is data pre-processing. So what do we mean by pre-processing and why is it important? So as we all know, natural language happens to be very, very varied. In the sense, what I say to convey a particular thing, Devendra, my friend here, might want to convey the exactly same thing, but he can use completely different words, right? So in certain sense, we need to reduce the complexity of the data that we have and present it in such a way that we'll be able to work on it. So these are the multiple steps that we have for data pre-processing. So what do is first of all, we do case generalization. In the sense, when I write, so I usually, by the rules of grammar, the proper nouns are usually written with the first letter as uppercase. So when I write Paris is an amazing city, so P will be uppercase, right? But Devendra uses Paris in the fashion, the city of Paris is a beautiful one. And by mistake, he has used beautiful, the B is uppercase, right? So now the machine does not understand the difference between a lowercase b and an uppercase b. It might consider that beautiful with an uppercase b means something completely different. But that's not something that I want, right? So I usually in natural language processing, we convert all the text data to lowercase. Then we have punctuation removal. So exclamations, apostrophes, commas, they might convey meaning at times, they might not. So depending upon your application, you might want to remove them. For example, if you're doing sentiment analysis, you might not want to remove your exclamation, right? Because exclamation is conveying a particular sentiment at that time. But I want to, maybe do some topic modeling. So I don't care if there's an exclamation or not, whether the person is asking a question or whether it's a statement. All that I want to check is whether what exactly the person is saying. In that sense, we remove punctuations. We have contraction expansion. So as I said, that language happens to be varied. Devendra uses it is a good day. I use it's a good day. IT apostrophe S, right? So if we directly feed the data to the machine, it's not going to understand that it's a day and it is a day kind of mean the same. Well, not kind of, exactly mean the same. The machine is going to get confused. Hence, I do contraction expansion. Depending upon whether you're receiving your data from, it might have HTML in it. HTML is hypertext markup language. So, for example, if you're maybe doing a REST API call on a particular website and using all that is present in the website, so it might be presented as an HTML. When we are putting this data for pre-processing, or when we're putting this data in the machine, we don't want it to understand HTML, right? So we do HTML sanitization. We have stop words removal. So while speaking, we use a lot of fillers, and which might convey certain meaning. At times, mostly doesn't convey a lot of meaning. The boy is going with the ball, and then they are going to enjoy. So, then a lot of fillers are there. What fillers do is at times they unnecessarily increase the size of the text. And if you want to do things like topic modeling, or if you want to do just count the number of important words in your text data, you will see that at times the, is, these are the words that are most frequently appearing. So this is kind of polluting your data. The is something that's always going to come, right? So we do a stop words removal. Now, stemming and lemmatization is when you try to reduce the word to its root form. So I am playing, Devendra plays. Now here, what is important to me is the word play. I don't want the machine to understand the difference between playing is something, it's like a present continuous tense, and plays is a present tense, so on and so forth. I want the machine to understand in both the sentences, play is happening. So I'll use lemmatization in this case. So the difference between stemming and lemmatization is that stemming just chops off the whatever is coming after the root of the word. Lemmatization, so in the sense, words that are stemmed may not actually exist. In the sense, if I can give you an example, this may not actually be the case, but for example, playing might be reduced to PLA, something like that. Okay. But with respect to lemmatization, we always fall back to the base word of it, and playing, plays, played will all become play. Moving on to tokenization. So the sentence as is highly unstructured, to say so, other than the rules of grammar. So what we need to bring more structure to it. So we tokenize them. In the sense, different words can be considered as one token each. Then we have bag of words vectorization. So basically we try to count. There are two sentences. After stop words removal, imagine I have these three things. Boy eats food, boy sleeps night. These are the two tokenized sentences that I have. Okay. So I'll count. So for example, I'll create a vectorized example of the first word, for first sentence. When I feed data to the machine, it cannot understand these words. All that it can understand is numbers. Hence, we convert these. So boy plays. So boys, I'll mark 1. Plays, I'll mark 1. Does this sentence have sleeps in it? No, I'll mark a 0. Okay. So, and then term frequency, inverse document frequency, what we are trying to achieve here, I'll give you a conceptual understanding of it. Words, I am interested in words which are present in the document. So a document is considered as a group of sentences, and I have 100 documents with me. Words which appear throughout the document might not be that important. They might be fillers, they might be stop words. Words which only appear in one document but do not appear in the other documents are very important. So using TF-IDF, I'm kind of trying to identify that. We'll quickly go through the Google notebook for this. You guys can, and I urge you to go through this notebook in detail. So this explains you what NLP is. We have used the NLTK library through which you can do the pre-processing. We have done tokenization, just, look at the tokens that are being created out of the text data. You see the length of all the tokens. We have the sentence tokenizer from NLTK. Stop words removal. So NLTK library already provides you with a stop words list. If you want, you can extend it or reduce it depending upon your application. So for example, I am writing I'm working on data sets from students, and students happen to use the word party a lot. And for my application, I don't want the word party to be in it, but party as such in the stop words list might not be a stop word actually in NLTK. So I can always extend the Python list.
As you can see, like the bunch of stop words which are present there, like words which might not convey any important meaning. Like they are just like was, shouldn't, should, be, like all these grammatical constructs which might make your sentence more structured by just speaking them. But if you want to process it, it might not be as important.
Now here, we are doing stemming. So now this is an example that I wanted to give you. For example, Senate has become SENAT. So whatever comes after it has been removed. This is stemming. So there are all these examples you can definitely go through. Then this is lemmatization. Yeah. So now see, Senate still remains as Senate. This is a difference in lemmatization and stemming.
So what are the two, like, so these ones, the two are like exactly the same, so like, what's the difference between the two, why is it a two?
So for example, the rescues, you can the word after among, so that the plural got converted to singular. So
I see.
Yeah.
Okay,
so in lemmatization, you would have a base word. So for example,
Anxieties. Anxiety is reduced to anxiety.
anxiety. Whereas if you would have done stemming, it would have become something like ANXIET.
Yeah.
um,
So
Anxiety.
the IES
Okay.
wouldn't be there.
mhm.
So
Yeah.
I think it's a modeling decision which you have to make. So you have both of them. So you pick whichever you feel is better suited for whatever you're trying to do. So it's an application based decision which you have to make.
The goal happens to be the same in both of them, that we want to reduce multiple forms of the same word to a base form, so that the machine understands that the same thing is being referred to at multiple times or in multiple places. Then we have parts of speech tagging. So these are a kind of models, I would say, and parts of speech. So what we have learned in grammar, yeah, nouns, pronouns, adjectives, and verbs. So you can tag them. We have named entity recognition, that what does a particular entity represent. For example, fellow citizens is org, the 14th day, it represents date, right? So on and so forth. We can also do spell checking and correction. Now, important point I'd like to mention here is what all tasks that you want to do in your pre-processing is highly dependent on your application. Okay, so if you have data, let's say from kids, so kids are they've filled some survey, yeah, so they are bound to make a lot of spelling mistakes. So in this case, spelling checking or correction might be a very important step for you. You are analyzing some data generated by ChatGPT. Okay, in that case, you might not want to do spell check correction, because ChatGPT is not going to give you, words with wrong spellings. Then we have removing the characters, punctuation numbers. You can use regex for this. We have the bag of words vectorizer. So this is what I was talking about. Yeah. So the first document or the first sentences has account, doesn't have an. That's why it is 0. Then we have and, it has and. Apprentice, we don't have apprentice, the word apprentice. So what we have achieved using this is, for all the words we have, for all the documents or all the sentences, we now have a common structure. Irrespective of the length of the sentence that initially was, we have the same length vector, right? Then we do, so using this, then we do TF-IDF vectorization. In a sense, account, how many, this number, what does this number represent here is, it's a numeric measure of the fact how many times account has appeared in line 1 as compared to how many times account appears in all the lines. I want to give more importance to words which are present in line 1 many times, but not present so frequently in all the lines.
So if I can add, like this measure of TF-IDF, it was primarily introduced for this task called information retrieval. So information retrieval is this task where, let's say you have, let's say you're working at the USC library, and you want to create a task wherein, like, if a person searches for some query, you want to retrieve the most relevant document. So here it would make sense because you can think of, like, let's say someone types economic, the inflation percentage across 1950s and 1960s. So if you would want to give importance to the word inflation, and to the here inflation is the keyword. Whereas, like, you might have a lot of books which have the word United States, so you would not want to give importance to that. So yeah, that is the basic premise behind TF-IDF.
moving on to sentiment analysis. So just before we start with this, are you following, or is it this is too fast or too slow, or this is good? Okay.
In sentiment analysis, we are trying to just get a basic idea of how a sentiment analysis work is done. So whatever you have learned about text processing, or getting the data and all that, so that all the steps have to be perfectly executed. In terms of models, which classification models you can use, now that depends mostly on what data you want to classify for. If you want to go deeper into having the nuances, then you can of course go for deep learning algorithms, and or otherwise a simple naive Bayes or support vector machines can do the trick for you. So evaluation parameter is going to be very important for you to analyze, okay, which model is giving me a correct or accurate result, what we expect. Okay, so let's just dive into that, into the sentiment analysis. So this is also a notebook. So in here we have used Hugging Face as a pipeline. So if you can see that instead of doing all the text pre-processing stuff that we discussed earlier, you can use an inbuilt pipeline which is already there. So you just need to tell that I need a pipeline for sentiment analysis. You have a pipeline which is already created. So whatever data now you have, you can just use it to get your output. So that's a very good thing for us, because then we can just work on our data and what model we want, or we can focus on our application rather than focusing on the other things like pre-processing and stuff. So you can just see we have this financial data set in which we have sentiment for different let's examples, like you have shareholders, or you have which are like neutral statements, positive statements, and negative. So this is how kind of what your data set will look like. Okay, and we have just input. We have the input for every sentence. We have inputted in this the model which we have taken from Hugging Face, and we're trying to generate a predicted sentiment. So and we are just checking if whatever predicted sentiment is the present, is it similar to whatever we actually had, to realize, okay, what's our accuracy with respect to the sentiment analysis data set that we have taken. So now, depending on the values that you get, you can decide, okay, maybe the model that was currently used is not efficient enough for the current data set, or do I need to add something, or maybe it's overfitting the data, it's trying to access everything correctly, but for the test data, it's not able to do it that well. So that's something you can just take a look from here. Yeah.
So I think one thing to point out is that, so generally when you predict sentiment, you either predict positive or negative, but people generally don't consider neutral.
Yeah.
So the issue here, why you're getting as you can see, like by eye test, you can see that there are a lot of mistakes, errors, which it makes. It boils down to the fact that in real life, you have a lot of statements which are neutral, whereas most of the models are trained on positive or negative sentiment statements. So if you'll have a domain mismatch most of the time. So when you're modeling your applications, there are a lot of things which you need to consider. And it could also be the fact that whatever sentiment analysis data which the model which we use is trained on might not be like financial data, and so it might not be able to capture that. So yeah, if this is something which you want to work on more, I think you can we can talk about it, or you can just contact us.
Moving on to the next one, that is topic modeling. So imagine what we have done till now. So for now, this relates to the modeling part of the pipeline that we discussed, right? So what we have done is we initially collected data. How did we collect data? Using REST API, using online platforms like Kaggle. Then we processed it using all that stuff that we were talking about, right? Stopward lemmatization, so on and so forth. Now, Oh, yes. Sure. If you mean the link for the Google Colab, so we'll be sharing the complete deck with you, and you'll be having access to all the Google Colab links and everything that's present inside the deck.
Just share it on
The link to the deck.
the link to the slide.
Yeah. Aditya, can you? Yeah. So Aditya is sharing the link. Till then, I'll continue with this. Yeah, that's right. So yeah, that was a quick summary of what we have done till now. Now we are here for the second task, that is topic modeling. So the use of topic modeling, so automatic identification of topics or themes from a large corpus of data. Where this might be useful is that on Amazon, you have a lot of reviews, right? People are commenting about your product. You want to identify what are the main topics they are talking about. One of the projects that I had worked on was topic modeling on surveys. So there was this big survey conducted in one of the firm I was working in regarding whether you like work from home or if you don't like work from home. So there are two tasks. First of all is sentiment analysis. We want to identify what the review is saying. Are they liking it or they're not liking it? That's the first thing. After that, if let us say Devendra and Aditya here don't like work from home, me and Aditya, the other Aditya, we like work from home. Now I want to identify why they don't like it and why do we like it. So now I want to do some topic modeling. The people who say that they are liking, I'm going to filter that data and I'm going to identify the main topics that they are talking about. Similarly, I'm going to filter data who don't like it and identify what are the topics they are not liking about. So you can, the kind of results that you can expect from is that people who are not liking it will say something like, the topics that will be modeled is lack of people to people connect. So these are some of the topics that I can learn from. Now, there are multiple algorithms through which you can achieve topic modeling. There is latent semantic analysis. We have latent Dirichlet's allocation, the one which I've used in the Google Notebook. We have NMF, non-negative matrix factorization. So what we will not be diving into too much detail of how these algorithms actually work. The reason that we have put it here is to give you an view that how you can go about achieving all these things. Right. So I'll just quickly move on to the topic modeling Google Notebook here. Yeah. So almost in every Google Notebook, we have tried to follow this format. Okay. So this is the link where I've used the dataset from. This is a link to the actual file, which is live on my drive. So you can directly use the file from there. And we have an article on topic modeling by TDS, stands for Towards Data Science. Usually their articles are very hands-on, so you can refer all of this. These are the library imports that we are doing. This is where I am directly reading the data from my drive as a data frame in Python. Data frame is basically just a table-based structure of data. Now, this is how the data looks like. So I have reviews from Amazon. Yeah. And I think we have also shown the size somewhere. Yeah. So we have 1597 entries. Now this is the complete pre-processing thing that we talked about, right? I am doing case generalization. I am doing contraction removal. So isn't and didn't becomes is not, did not. We are doing punctuation removal using regex. We are using tokenization and lemmatization. Instead of using stemming, I've used lemmatization here. We are removing the stop words. All of this complete pipeline is already been written and you can directly use it in Hugging Face. But this is just for your information. Now, after this is how the processed review text. So this is the actual reviews that I had. Now this is the processed one. Look at this. I initially had trouble deciding between after removing all the stop words, removing punctuations, we have initially trouble decide paper white, so we have enjoying has become enjoy. So now I guess you can understand why I was removed. I was removed as parts of stop word removal. initial had was removed again and stop was removed. So now I guess you can appreciate what is happening from this to this, right? Now I'm just displaying the most common words that I have in my data set. So usage, Kindle, fire, like, Amazon, wood, sound. So these are some of the words that are appearing many times. Now, this is kind of an evaluation, right? So now we can again go back to the pre-processing modeling. So for example, if I think that use, would, these are not the words that I'm interested in. What I can do is I can add them to the stop words list, right? Now, this is the bag of words. We have generated how many times a particular word appears. And then we have used something called as the coherence score. What the coherence scores, for example, what is the number of topics that I want to identify? So coherence score is something that will tell me that how many topics you should go with. So this is the coherence graph. So this kind of tells me that maybe 8 topics. So this is too less, but 8 topics, something near about this range is. So I should be using 8 topics. So then using topics equal to 8, we do the modeling. So I've used GenSim. You have the latent Dirichlet's allocation. Now these are the different topics that have been generated. Now I'm using a Pi module, Pi LDAVIS module to visualize. So there are these total 8 topics. The farther the clusters are, so 8 is very different from 1, but topic 2, 5, 7 are very similar to each other. The value of lambda is gonna tell us how. So when I click on a particular topic, lambda value is gonna indicate the importance of words inside that cluster that are being shown on the top of it. And these are the different words that belong to topic 4, words belonging to topic 2, topic 6. Yes. And all of this that we did till now can be easily done using the transformers module, that is the Hugging Face module. Yes. All that was happening above is being achieved in just these many lines of code. Pre-processing, topic modeling, coherence, everything, right? So it's up to you what you want to use. I suggest you go through both of the approaches so that you have an understanding of what is being done. But finally, for your project, you might want to use Hugging Face. Yeah, that was about topic modeling. Moving to text generation.
So as we have seen, like the chatbots like ChatGPT, they are trained on data set which are very huge in size, and so to encompass all the data that it will train on, and you need a large number of large data set and large number of weights as well to so the model which will be created will be very huge and will require a lot of a memory and computation power. So it won't be easy for you to just do it on your laptop or PC, so you need a much larger code as well as actual physical devices. So if you want to do something related to text generation, I'll recommend you to use Hugging Face and use the transformers which are already created. So basically the models are already been created. They already have the weights and biases and everything trained on. So here we are using the OpenAI, the ChatGPT, the GPT Neo. So this is another. So if you can see, we are trying to see, okay, what's the input? We have given an input text here, and we're trying to generate a sentence of maximum length of 40 from this ChatGPT. So you can just search on Google as well. You'll find a lot of resources about pre-trained transformers. So here you can see it has over 2 billion parameters. So like this is not something we want students to do on their own or try to train something, because it won't be as effective as you want for your application. So instead, just use the Python transformer. And as you can see, we've given a starting of the text, like the ChatGPT is very much. So it has generated words which we haven't given any input at all. So it's using the input and trying to create text from it and so on. So if you want to create any chatbot or something, such an application, I would recommend you to use this transformer and get on with your application. Following it, let's just consider the NLP methodologies. So basically, there are three types of models that you can use. First will be the rule-based models. Let's say you are a bank and you want to have like a customer. So if you want to see what the customer has done over in a year, so you need like a number of transactions he has done. What's the total inflow of money and outflow. So these things they will be same for all the customers. So any customer you click, he's going to give you the same paragraph. So basically you can create rules depending on what their income is. You can have different sentences and all that, and you can just add it to your output and use it. If you want to go a little bit in depth, you should use machine learning algorithms to classify text, extract information, or you want to generate any new content. So machine learning is the way for you. The only problem is then you require a large amount of data to train your machine learning model on. So that's something which will be expensive, not just computationally, but you have to then go on looking for correct data sets, remove biases and all that. So so that is something you need to check for your application. Finally, you have the deep learning model, which uses neural networks to analyze text. So this is very robust because you can make decisions like regularization, and you can use dropouts to make sure that even if you have some values which are like not present or anything like that, neural network has the ability to not take that examples into account while creating the model, and it can just forget that and move on. So let's go dive deep around neural networks for machine learning. So basically, neural networks were created based on the brain architecture. So you have neurons which are which are stacked together, and you have multiple layers of neurons, and collectively they will function to give some neural impulses to do an action like speaking or hand gestures and so on. In the same way, if you can give input to one layer of neuron, you can just check this out. So like you can give input to one layer of neuron, and those layer will do some computation on its own, and whatever the output that neuron gets, it will be transmitted to the next layer as an input. So now you will have like layers stacking with respect to each other, and each layer can have like multiple computations. So it will generate new features or try to get different things out of the input, and together then we will create two outputs. Let's say maybe you want to figure out if the sentence is positive or negative, or you want to check out, okay, should we give loan to a bank person if you are doing classification, or maybe you are giving it a input in image, then you want to see if it is a cat or a dog. So all those features will be extracted during the hidden layers, and it will be generate an output like a binary value or whatever your application looks for. So why are we using neural networks? Even though we are saying, okay, you are going to have multiple layers, it will have more parameters, and it requires a lot of data. It's because it can handle noise, it can handle incompleteness, it can help to accept multiple data sources. Like it can do text, it can do image recognition, speech. So whatever type of data you have, a neural network will make it better, and it can help you do computations on it. So that's why I think you should use neural networks. Finally, for the recurrent neural networks, the thing is your text may, or like it's not like the first three words of your text are going to define what is coming next. So like if you say he said the teacher said students, that's afterwards he can say students go sit there, or students please come here. So the last part of the sentence is also equally important as the first part of the sentence. You can't just say, okay, from the first 3 words, you're able to guess this on. So with recurrent neural networks like bidirectional RNNs and so on, you can make sure that the end part of the sentence is also used while using the computation and so on. So just want to quickly go over the RNN using Python.
Yes. So I'm gonna dive into RNN a bit since we have time. So bear with me, and if I use a lot of technical lingo, just let me know this is getting a bit out of hand here. So first of all, in earlier lectures also we have studied neural networks, right? If I'm not wrong, in the machine learning workshops. Yeah, a bit. Yeah. So, and considering that we know neural networks, so let us say I'm trying to do a classification task. I'm not related to language at all. Okay. I have different parameters, like I want to identify the price of a house. Yeah. A regression based model. What I have, let us say, the locality of that house presented in some sort of numbers. Okay. The current market trends and the number of rooms the house has. These are the 3 variables that I'm going to use to predict the price of the house. Okay. Now, the number of rooms this house has no relation with the current market trend of houses. Right? Right? The number of rooms this house has no relation to the, let's say, what was the first parameter that we had, the locality of it, right? So these are independent parameters, and we feed them independently or in parallel to the neural network. All these features are input as an input to the neural network here. Where is our PPT? Yes, x1, x2, x3, these are, or till xn, are different parameters that are being fed simultaneously to the neural network. But can we do the same with language? Can we do the same with sentence? No. The reason being, sentence has some kind of an inherent structure to it, and the meaning of the word depends on what comes before it, and at times also may depend on what comes after it. For example, today's lecture is really interesting. Haha, I'm kidding. Okay. So till then I don't add haha, I'm kidding, you don't get that I'm using it as a sarcasm, right? So the meaning of the sentence here depends not only on what comes before, but also on what comes after. To give you an example from real world, imagine stock prices. The stock price of a particular ticker today will not only depend on all that is happening today, but also on something that happened yesterday. Yesterday, the stock was very bullish. In the sense, it was bought a lot. The price went very high. It may come down today. More likely than not, it's gonna come down today, right? So this is the reason that we use recurrent neural networks. So this, in a very loose sense, the output of this A1 will be fed to A2. Output of A2 will be fed to A3, and so on and so up till AN. So what I am trying to do is, I'm not only trying to take in the effect of X2, but at the same time, I'm trying to understand the effect of A1. Okay, so this is what neural nets are actually trying to encompass. Okay, so this is what RNNs are. Are you kind of comfortable with the idea of what RNN is? Now there are certain problems with that. Imagine in a normal setting, in the normal setting of the housing model that we were talking about, you can feed all the features in parallel, and all these computations from x1 to a1, x2 to a2, xn to an, all of these computations can take place simultaneously. But when I am providing the input of A1 to A2, A2 has to wait to do its computation. It has to wait for what? A1. A3 cannot compute till then it has the value from A2. In the sense, I will have to feed all of these x1 till xn sequentially. That makes my program run very slow. And at the same time, some lingo alert, technical lingo alert, we have a problem of the diminishing or exploding gradient. Now, what is meant by that? So, as we all know in neural networks, consider A1 as W times X1 plus B. Okay, as a numeric function. I'll repeat that. A1 equal to what? A1 is equal to W1 star X1 plus B1, where W and B are basically weights and bias. What is a weight? We are just multiplying a number. And what is bias? We are just adding something to it. So let's say A1 is equal to 5 times X1 plus 2. 5 is my weight and 2 is my bias. Now what happens is A2 will take the effect of A1. So I am going to have W1 times X1. A3 is going to take A2. So it's gonna take W2 times A2. But what is A2? A2 is W1 times A1. So what is happening is A1 is being cascaded. So initially A2 was using 5 times X1. A3 is going to use 25 times X1. A4 is gonna use 625 times A1. In the sense, this 5 factor is getting multiplied. This 5 factor, we call this as a gradient, not exactly, but I'm giving it to you in this some kind of loose terms. So can you appreciate that by the time you reach AN, imagine how high the value will be. And hence it is called as an exploding gradient. Versus, let us say, if I have the value of this 5 between 0 and 1, I'm using, let us say the value is 0.1. So this, let's say, what is 0.1? 1 divided by 10. So by the time it comes to AN, imagine what it will be. 1 divided by 10 to the power 20, something like this, very close to 0. Hence known as the vanishing gradient. How do we deal with this? We deal with this using something called as long short-term memory. What does LSTM do? And bear with me, I'm just gonna complete this and wrap this in 2 minutes from now. Long short-term memory. So what was the issue that we were facing? The issue that we were facing is to understand this memory, to record this memory. So basically, whatever comes from X1, X2 should know. Whatever comes to X3, X1, whatever comes to X3 should have X1 and X2 in it, right? So this, in a sense, is something called as memory. LSTM uses 2 channels. It maintains a long-term memory and it maintains a short-term memory. Okay, are you comfortable with this idea? Yeah. So now what has happened is, using this long-term and short-term memory, we have overcome the issue of this gradient thing that we had. Okay, now everything's going fine. But LSTM still happens to be very slow and very complex. And then there was a great paper that was highly talked about, was released in 2017, called as Attention is All You Need. They introduced 3 things to a LSTM. The first was positional encoding. Positional encoding means, in a sentence, for example, I have Devendra is sitting on a chair. The position of the word Devendra is added to the numerical representation. Devendra is comes second, sitting comes third, on comes fourth, the fifth, chair sixth. So when I am creating those vectors for these words, I'll be adding the meaning, I'll be adding the position of where the word is coming. Because now I think we can appreciate that in language, where the word comes is very important, right? This is what they added to it, positional encoding. Second is they added something called as attention. Attention, in a nutshell, is a way to understand the word with respect to its neighbors.
You can go to the slide before the previous slide. Yeah. So if you can see, the RNN here only considers the words which are before. Whereas in this new construct called, which they defined as transformers, you can see that each word is attending to every word in the sentence. So in this way, they wanted to, in some form, like avoid the sequential computation, and they also like made it such that you could parallelly. So they kind of went back to this neural network model, wherein you can send everything parallelly, but at the same time, you were attending to every other time. So this is what made this construct of transformers very powerful. And I think most of the modern day deep learning models which you see will be built on transformers. And I would suggest, like, if anyone who's interested, if you want to get started off using these transformers in Hugging Face, and if you guys would want, I think we can go on and probably give a demonstration of it in the next workshop.
Yes. So in a nutshell, 3 things were introduced in transformers: positional encoding, attention, and self-attention. Okay. So now what have we achieved using transformers? This is what we have achieved using transformers. You can feed the words. For example, the boy plays. X1 is the, X2 is boy, X3 is plays. In RNN, I had to first feed the let it get processed. Then boy, let it get processed. Then plays, let it get processed. If I try and feed the boy plays at the same time, the is being processed individually, boy is being processed individually, plays is being processed individually. But the machine fails to understand who is playing. It just knows plays. Now using transformers, using attention and positional embedding, I can simultaneously, parallelly feed the boy plays, and at the same time, boy is being processed with respect to plays, and the plays is being processed with respect to boy. In the sense, we have achieved best of both the worlds. Things can happen in parallel, and at the same time, when things are being computed, they are being computed with respect to their neighbors. Using this architecture, what this architecture made possible was for the models to train through huge amounts of data. And when I say huge, I mean every word in English that was ever written and is present on the internet. Every English word that was present, that was written and is publicly available on the internet has been read by ChatGPT. And that is what makes it smarter, but admittedly dumb in some things, that it's not creative per se. But okay, that's a topic for another day. Up for debate, definitely up for debate. So yeah, we have the link to attention is all you need. And yeah, sorry, we were supposed to go through the collab initially. Yeah, so this is the RNN using PyTorch. And yeah, so basically we are using this module from PyTorch. These are the imports, torch.nn as NN. Yeah, thank you. Yeah. And we have something called as so every NN is trained in 2 ways. We have a forward propagation, we have a backward propagation. In forward propagation, we are just calculating the values. In backward propagation, we are trying to improve on what we just calculated. And you see that the loss is reduced. So that's a good thing across the epochs. And you can, again, play around this notebook as much as you want. So yeah, that was about RNNs. We covered introduction to transformers as well. And this is, please don't get afraid looking at this slide. This scares me as well. So all these yeah, so this is the actual working of a transformer. There are, just to go over a very high level view of it, we have something called as an encoder and something called as a decoder in transformer. And yeah, so this is how they work. So why transformers? So as we said, that transformers model semantic and temporal connections between the sentence better than the neural networks. And the gradient vanishing and explosion, which we talked about, the encoder of a transformer can act on the entire input sequence in parallel. So this is all that we just talked about. Yeah. Now, yes. Now this is an assignment for you guys. Just a minute. Is there something in the chat? Can you check the chat? Okay. Yeah. So yeah, this is the assignment for you guys. What we are trying to do is detect fake news. So as you know that in social media, there are a lot of things that are being shared, but a lot of them might be fake. So is there some way that the machine can identify what is fake and tell us that? So we have divided the assignment into 6 parts. In the first part, you will read the data, create the target label, merge fake and actual news instances. The link to the data set is provided here. It's an, I think there are about 23K fake news and 21K true news instances. If you want, you can always use a subset of that. Okay. Yes. So now, then you pre-process the data using NLTK as required after your analysis. So we want you to look at the data and pre-process it using the things that you want. So if you want to do case generalization, do it. If not, try it without that. Then visualize true and fake data using word cloud. So try to identify what are the main words that are being used. Then vectorize the data using TF-IDF. Fit the data to classification models from sklearn. So you can use multiple classification models, knife Bayes, KNN, decision trees. You can use a multi-layer perceptron, and you can also go with Hugging Face for classification. And then assess the accuracy and use the confusion matrix to identify how much you scored, right? The solution link is already available with you. I would urge you not to click on this till then you are done with it, but you can also always use this as a final reference. These are some discussion points that we want you to think on. So, Angela, are you there? Can you hear us? Okay. So basically, these are quick questions that we want you to ponder on. And once you have gone through this video, we can discuss on Slack channel that what NLP tasks will you be using to attain these or solve these questions. So please go over them. And yeah, these are some of the project ideas that you can refer to, and we can discuss on this on the Slack channel definitely. And these are all the references that we've used for today. And please go through all these links. You can view the video again, and you can also go through all the Google Colabs. And again, cannot emphasize enough, this is not something that you can learn in a night, but continuous effort is required. And wherever you want some help, we are definitely here to help you. Thank you so much.